Okay, so I request everyone first note down the sum. The shear strength parameters of a soil are C dash 26.7 kilonewton per square meter, pi dash 15 degree, C dash M is 17.8 kilonewton per square meter, and pi dash M is 12 degree. Calculate the factor of safety with respect to strength, with respect to cohesion, and with respect to friction. The average intergranular pressure sigma dash on the failure surface is 102.5 kilonewton per square meter. So this is a very simple and straightforward sum. So two sets of data has been given. If you look at the C dash and C dash M, in a sense, you can understand that the C dash and C dash M and pi dash M both are of effective stress form. Okay, the only difference is that the designation M refers to mobilized cohesion and mobilized angle of internal friction. So if you refer back to our previous class discussion, so it says that the C dash and pi dash values are belonging to the strength at the failure or shear strength parameter at the failure, meaning thereby when cohesion and angle of internal friction attains to the value of 26.7 and 15, your soil literally fails under shearing mode. Okay, but before the soil started failing or before the slip surface or landslide has occurred, but there should be some triggering point that is called as a mobilized shear strength parameters. Those are called as C dash M and pi dash M. That means you can understand that your failure, that is the condition called as the incipient condition of the failure, has commenced when the shear strength parameter has reached to 17.8 and 12 degrees centigrade respectively. 12, not centigrade, 12 degree respectively. Okay, now upon further increase in the stress, then the shear strength further decreases. Once it reaches this 17.8 to 26.7 and 12 to 15, so there is a dislocation of the mass leading to the landslide. That means when it reaches to C dash and pi dash value, there is no more slope exists in that location. Okay, this is what is the difference between C dash and C dash M. So please try it from your side. Calculate the factor of safety with respect to strength, with respect to the cohesion, and with respect to the friction. You may refer back to your previous class notebooks to see the formula corresponding to the factor of safety with respect to strength, cohesion, and friction. Anybody?
Sir, factor safety with respect to strength
Yeah.
1.368
Okay.
and with cohesion, sir, 1.5 and
Okay.
with friction 1.261.
Okay. Others, could you please confirm?
I'm getting same.
You're getting the same. Okay. Very good. Okay. So let's see. So first of all, you need to calculate the shear strength corresponding to the failure, that is the ultimate shearing condition and the shear strength corresponding to the mobilized state. So those are called as a average shearing strength at the failure condition and the mobilized shearing resistance. So the ratio of these two is nothing but your factor of safety with respect to the strength. So if you look at the fundamental equation to determine the factor of safety, Fs is nothing but strength, the average shear strength at the failure divided by the average shear strength at mobilized condition. So this is 1.37. I think hope everybody has got right value of 1.37. So if not, please verify. Then with respect to cohesion means we have to take only the cohesion value, which is very simple. So simply take the ratio of C dash by C dash M, and with respect to the friction, it is tan pi dash by tan pi dash M. So hope everybody got the answer. So Fs with respect to strength, yeah.
Sir, one question, sir.
Please.
Sir, why we are considering separately by with respect to cohesion and with respect to friction, sir? Since with respect to strength is more relevant, na, sir?
It is true with respect to strength is more relevant, but for a given soil, just imagine when you are trying to determine the shear strength parameters in the form of a C and in the form of a pi, most of the studies say that it is or whatever the methods so far which have been developed for determining the C and pi, among them only pi methods are reliable. However, there is no exact method to determine the C value. Okay, so therefore there is some kind of an uncertainty lying on the cohesion term always. So that is why we always bit skeptic about the value of the C. We always use some kind of the factor of safety with respect to the C value, while the pi value is more reliable. On the other hand, it is also important to understand which parameter is governing your stability. For example, Fs, it will give you the total shear strength value, but it is masked the effect of either cohesion or the angle of internal friction or the pore pressure parameters. We do not know because this constitutive equation is a combination of all the parameters. But if I want to figure it out which parameter is more influential, then I must determine the factor of safety with respect to the cohesion and angle of internal friction. In fact, this is very simplistic way of deriving the parametric sensitivitiness, but let's see another sum where you can further understand which parameter is more important among the cohesion and the angle of internal friction. So let's see the next sum.
So, sir, for the given question,
Yeah.
with respect to friction is more critical.
We cannot say from this simple one.
Yes, sir.
Okay, so since its value is on 0.26, then you are saying it is a critical. Okay, but suppose if you take the realistic condition, losing the cohesion is much more easier than the losing the friction. You got it?
Yes,
In,
sir.
in practical perspective, the friction always more reliable than the cohesion. The moment you, as for example, if you recall to the very first discussions of the applied soil mechanics, you have taken the soil. Suppose if you introduce water of the soil, which is governed by the cohesion and which is governed by the friction. So it is obvious that there is a dominant effect of the moisture content on the cohesion, but almost you could see there is no effect of moisture on the frictional soil. Okay, the angle of friction is remained same whether it is completely saturated or it is a dry condition. But that is not the case in case of the cohesion. I hope you understood this logic.
Yes, sir.
Okay, that is the reason normally we consider we always recalculate the factor of safety by varying the parameters also. Anyhow, let us take another example. The above example shows the factor of safety with respect to shear strength. Fs is equal to 1.37, whereas the factor of safety with respect to cohesion and frictions are different, as we have seen. Now, consider two extreme cases. When the factor of safety with respect to cohesion is unity, and when the factor of safety with respect to the friction is unity. So then what is the final factor of safety? Or what would be the value of the factor of safety with respect to the strength? So this is how you need to calculate. So first case 1, where it is said that the factor of safety with respect to cohesion is unity. So then what would be the factor of safety value corresponding to the friction? Okay, so now we know the ultimate shear strength is 39.6, and now there are two terms, that is tau is equal to C plus sigma dash tan phi. Now it says that corresponding to C, so if I take the factor of safety is equal to, or the mobilized is equal to C dash by factor of safety. So here the factor of safety with respect to cohesion is unity. So you need to take 26.7 divided by the 1 plus the sigma dash by the f pi. So that is, you are asked to calculate the factor of safety with respect to the friction. Then tan pi, this is the given the friction angle. So then if you calculate the factor of safety with respect to the friction, what you will get is 2.13. So 2.13. Okay, this is keeping the average shear strength or considering the ultimate shear strength. Now the case 2, same repeat. So in that case, take the friction with respect to factor of safety with respect to friction as unity. Now in that case, so I need to back calculate, considering the ultimate shear strength of a soil, what would be the factor of safety with respect to the cohesion if friction is unity. Yeah.
So when we calculate using the ultimate values, then tau comes out to be 54.16.
Then you need to calculate against the mobilized one. This is mobilized or ultimate? Oh, sorry, this
Mobilized
is
one.
mobilized. Okay, fine, mobilized. Okay, so this is another case. So now here you are getting the factor of safety with respect to cohesion is 2.2. Okay, so this is summary of the so far what you have done the calculations. Okay, now if you tabulate all the values, first let us see the first condition. Now when you have assumed the factor of safety with respect to cohesion as unity, you got the factor of safety with respect to friction as 2.12. And when you have assumed the factor of safety with respect to strength, then with respect to the cohesion is 1.26 and friction is 1.5. Okay, similarly this is also same 1.37 and this is with respect to the strength, assuming the factor of safety with respect to both cohesion and the friction is unity, then this is the final factor of safety. Or the another way, so this is factor of safety with respect to cohesion is 1.5, then the factor of safety with respect to the friction is 1.26. Or if you assume the factor of safety with respect to the friction as unity, and this is the value of the factor of safety with respect to the cohesion that has been calculated. Okay, so this is a short summary about the assumptions based on the factor of safety with respect to the strength, and the factor of safety with respect to the cohesion, and the factor of safety with respect to the friction angle. Or if we assume the parametric sensitivity, that is assuming one parameter is unity, then how would the other parameter is varying or influencing the final factor of safety values.
Sir,
Yep.
I have a confusion. When we are here considering mobilized one, then tan should be 12, it should be mobilized also now. Then the factor of safety with respect to cohesion comes out to be 1.2.
Okay, let me see it. Why there is so this is 39.6 tan pi. Actually, shear strength is this one. Okay. Shear strength you have taken 39.6, but 26.7. Oh, actually there is small mistake. Yeah, that is tan 12. It is not tan 15. Okay. So please everyone.
No, sir, this is right, sir. 10-15 is right, sir. Because we are dividing the this factor of safety, we convert to
Okay, okay.
final cohesion or ultimate cohesion.
So 26.7. Right. So you are taking 26.7 by. Yeah. This is correct, na? This is correct. So actually, you are determining the factor of safety uh, when you take the cohesion or the friction, but you need to take the incipient condition. Okay, so here you are taking 26.7. So here also you should take 50. So suppose if I take here 54.7, so it doesn't make any sense here when you take FC and F5.
Sir, what is significant of that combination of FC and F5? Can you please
See,
relate this in practical way?
so this is the practical aspect now. Now, suppose if you look at this tabular form, you can understand what is happening to the final factor of safety value or factor of safety to with respect to the cohesion or with respect to the friction angle. Okay, so from there you can derive which parameter is more influential or which parameter is more critical. See, one thing is there should not be much variation in the factor of safety value under any circumstance. If there is a too much of variation, it is a danger. You got it? So
So,
that
sir,
way,
according to you, for what parameter will be designed?
uh, it is not what parameter we will design. So we will understand the condition, which condition is making the slope the most unstable. Okay, so we will not design or something. We want to analyze which condition is making the stable vulnerable for the failure. That's what we need to understand. So when you vary all these parameters, corresponding to which combination the factor of safety is least. So that point you need to highlight. Anyhow, so this is only the initial. So let us take some more examples, then you can understand in a much better way. Okay, so any other question?
Sir, all values are above from one value. So, factor of safety means it is a safe structure.
One means on the verge of failure. One means on the verge of failure. Ideally, you can refer to some codal provisions regarding the value of factor of safety. So the factor of safety for static condition is different than the dynamic condition, than the seepage condition, than the liquefaction condition, so on and so forth. So many codes prescribe that under static condition, the minimum acceptable factor of safety is 1.5. But under dynamic condition, the minimum acceptable factor of safety is 1.2. 1.2. Okay. and the values are different again if you consider the full seepage condition or the steady state seepage condition or liquefaction condition, so on and so forth. So all these conditions differs, or all these conditions might vary your the factor of safety FC and FY. Okay, so here we are taking we are presuming no such condition like dynamic or seepage. This is simple static condition. Okay, now let us take the another sum. What will be the factor of safety with respect to average shearing strength, cohesion and internal friction of a soil, for which the shear strength parameters obtained from the laboratory test are C-33 kilopascals and pi dash 18 degree. The expected parameters of mobilized shearing resistance are C-M 21 kilopascals and pi dash M 13 degree, and the average effective pressure on the failure plane is 110 kilopascal. For the same value of mobilized shearing resistance, determine the following: factor of safety with respect to height, and the factor of safety with respect to friction when that with respect to cohesion is unity, and the factor of safety with respect to the strength. Okay. Now this is one of the beautiful example where you are going to get a set of data of the factor of safety values. From there you can understand which condition is the most critical for the stability of the slope. So almost first half of this sum is repetition of the previous sum. So you have been given C dash, pi dash, C dash M and pi dash M. So the calculation of Fs, Fc and Fy is straightforward. So can anybody tell me the factor of safety with respect to the strength?
Sir, height is not given.
No, you need to calculate the factor of safety with respect to height. That I will tell you how to do it. So here, see, factor of safety with respect to height, it is asked now. The height becomes critical when?
But sir, by formula we will find the critical height, and we have to just relate with the actual height, na sir?
No, no, no.
Okay, sir, we will find the mobilized height.
Don't need to. See, first of all, factor of safety with respect to height, it is set. So the height becomes critical when Fs is unity or Fc is unity or Fy is unity.
Sir, Fs is unity.
Okay. So then you presume the same condition.
Sir, give us 5 minutes. We can do.
Because you know the mobilized shear strength and ultimate shear strength. Okay. So corresponding to this strength, what could be the possible height if you take the factor of safety with respect to either height with respect to cohesion or height with respect to the friction? I hope others. The first three are straightforward, so there is no issue. But when it comes to the height, so you are asked to determine the factor of safety with respect to height. But which strength do you need to take? Average shearing strength or the mobilized shearing strength? But again, so if you are assuming either on the basis of average shearing strength or the mobilized shearing strength, you need to link the critical height with the factor of safety value. So let me show. So first, the available shear strength of the soil that is under ultimate condition is, so tau is equals to C dash plus sigma dash tan pi dash, that is 67.8 kilopascal. But the soil mass, starts mobilizing or it starts developing the incipient condition of the failure when the mobilized shear resistance so reaches to 46.4 kilopascals only. Okay, so when the shear strength or the shear stress reaches to 46.4, then the pressure builds up inside the soil mass, and it simply goes on. It won't fail so immediately when the shear resistance or the shear stress reaches to 46.4. It could still able to take some more load. Okay, so if you keep on further increasing the normal stress, then the shear stress increases from 46.4, and when it reaches to 67.8, it simply collapses or landslide occurs. So now I know the ultimate shear strength and the mobilized shear strength. So your factor of safety with respect to average strength is nothing but 67.8 divided by 46.4. So shear strength upon shear stress. So this comes out to be 1.46. 1.46. Now you also asked to determine the factor of safety with respect to the cohesion. So which is very straightforward again. C dash by C dash M. So 32 divided by 21, that is 1.52. 1.5. So now factor of safety with respect to the friction, that is tan pi dash by tan pi dash M. So tan 18 by tan 30. So 1.41. 1.41. Here you can look at, so the overall factor of safety with respect to average shear strength is 1.46. So with respect to cohesion is 1.52. With respect to the friction is 1.41. So among these three conditions, it shows that with respect to the friction is the critical. With respect to the friction is critical. Next. So here you are asked to determine the factor of safety with respect to the height. Okay, so your height f of h so can be critical when the factor of safety with respect to the friction is unity, because this is the worst condition. So among the three, so therefore you take f pi as a unity. So then correlate the factor of safety with respect to the height. So with respect to the height, fc, fh is equals to fc. So then you, once it is correlated with the fc, so put it in the same equation. So take the mobilized shear strength, and take the ultimate values of the shearing c dash and pi dash. So 32 by fc. So where this fc is linked to the critical height of the slope. Critical height of the slope. Okay, again you can also see that the critical height is related to the mobilized shear strength, not the ultimate shear strength. So 32 by fc plus 110 into tan 18 by 1. So therefore fc is equals to 3. So this is same. Now the case 2 is the factor of safety with respect to friction at fc is unity. So this already you have exercised in the previous sum. So repeat the same thing. So corresponding to shear stress of 46.4, then what would be the f pi value? So when you consider fc is unity. So the shear stress is 46.4. Then c dash by fc 32 by 1 plus, so sigma dash tan pi dash by f pi, tan pi dash by. So if you simplify this equation and try to determine the f pi value, so it comes out to be 2.49. 2.4. So then the last part is the factor of safety with respect to strength fs is obtained when fc is equals to f pi. fc is equals to f pi. So here fs is equals to fc is equals to f pi. So take the mobilized shear strength as 46.4 and equate the shear stress with the shear strength. However, that shear strength divided by the factor of safety, which is desirable. So 46.4 is equated to 32 by Fs plus 110 into tan 18 by the Fs. So if you simplify and calculate the factor of safety value, so Fs comes out to be 1.46. Okay. Now, if you try to infer the valuable information from all these factor of safety values, one thing is very clear. So your slope is becoming unstable only when you consider the factor of safety Fc is equals to F5. F5, that is 1.46. So no problem to the slope with respect to the critical height because the factor of safety is very high. So it's almost 3. And even if you assume the Fc is equals to unity, still the factor of safety with respect to pi is very high, 2.49, no problem. Okay. So here this indicates that the combination is playing dominant role than the individual parameters. So that's what is the takeout from this sum.
Sir, if S equal to FC, that is the essentially the same case as factor of safety with respect to shear strength, na?
With respect to shear strength, correct. In a sense, you can understand here. Say I have taken shear stress, I have taken the shear strength. So your Fs is nothing but shear strength divided by shear stress.
But sir, where is factor of safety with respect to height?
There is no factor of safety with respect to height because no height has been given. Okay. But from the calculations, say for example here in the above three calculations, you need to see which condition is more critical. See for example, with respect to average strength is 1.46, with respect to cohesion is 1.52, with respect to friction is 1.41. So among these three, so with respect to friction is becoming the least highest vulnerability. Okay. So now if you ask to determine the the height of the slope, So among these three, which one you have to take as a critical?
Sir, in previous slide, we already found the value of F. Yes. So why to recalculate after second in the second slide?
It is not recalculating. It is based on the assumption. See here I can also do one thing. Suppose the factor of safety with respect to strength Fs is obtained when Fc is equals to F5. Now here also same assumption is made. In this case also same assumption is made. Know the factor of safety value with respect to the cohesion or the friction has been imposed. But what if I take different value of the Fc and different value of the F5? Here instead of Fc, this Fs I will replace with the Fc of one value, and this F5 I can replace with the F5 but of different value. So then will you again get the 1.46? No, it is a different value.
Then, sir, how can we find fs if fc is different, fi is different? Then we don't have any term related to fs in this
Okay.
equation.
No, no. Just imagine. Say, for example, you have conducted triaxial testing and you determine the C dash and pi dash. C dash and pi dash. Okay. So these values are obtained. But by some means can be able to understand at what C dash m value and what pi dash m value the slope is going to be, the failure is going to be triggered. Anybody?
Sir,
How?
what is your question, sir?
See here, I have given C dash and pi dash, C dash m and pi dash m. Okay. And I can able to determine C dash and pi dash value by conducting the triaxial testing in the laboratory. But can I able to calculate in the laboratory C dash m and pi dash m?
No, sir.
No. But can I able to understand or can I able to calculate approximately this much value of the C dash m and pi dash m, the slope failure triggers?
Yes, sir. By trial and error method, we can find.
That is a different issue. Here there is no trial and error. Na? The trial and error is in case of rotational surface.
Yes, sir. Sir, here mobilized value can be find by taking some of the references, sir, means taking us some particular value, then what will be the consequence?
But how do you assume that particular value?
So first we can find the ultimate shear parameter. So by decreasing the some amount of values from these two values, c dash and phi dash, we can check the factor of safety.
Okay, so that is the one way. That is the one way. Or else simply what you do is, suppose if I want to understand the mobilized cohesion and mobilized angle of internal friction, you fix the factor of safety. See now we know, see Fc is nothing but C dash by C dash m. So in reality, I know the value of the factor of safety with respect to the cohesion. For example, in reality, I know the factor of safety with respect to the shear strength. Say for example, my minimum requirement is 1.5. I can straight away take Fs as 1.5. I can able to calculate what would be the shearing resistance at which the slope starts failing. Okay. But when I do so, I'm making an inherent assumption. That inherent assumption is when I assume Fs as 1.5, I am inherently assuming Fc is equals to F5. Do you agree this one?
Yes, sir.
Okay. But what if I assume independently Fc value, independently F5 value? Because I want to know whether cohesion is triggering the failure or friction is triggering the failure. To understand that one, so we need to assume Fc value differently and Fi value differently. Maybe you can assume F2 is say 1.3 or I assume Fi as 1.2. Then I will calculate the shear stress, shearing resistance. Then I can calculate the overall the shear strength. So this is the another way.
Okay, sir.
Okay, now did you understand? Okay, doesn't give any answer. Did you understand what I mean to say?
Yes, sir. One fact, these two factors of t is same. Then we will get the fs as 1.5. When
Yeah,
we put some as a constant and vary one parameter, then we will get different fs value.
true. Others, Binish.
Like in previous we have done a sir combination of fc and fi by
Yeah,
putting one value is constant and one value is vary, we can
yes,
have a different value.
different one, obviously. Others, please confirm.
Yes, sir, got.
Okay, very good. Okay, so that's very fundamental. Now let us go to another example on the infinite slopes. Yeah, note down. So note down the sum on infinite slope. For the infinite slope with a steady state CPA shown in figure 15.9, that is below figure, determine the factor of safety against sliding along the soil rock interface. The height h that will give a factor of safety fs of 2 against sliding along the rock mass.
Sir, give us few minutes to do, sir.
Yeah, yeah, no problem. So first note down. So then I will show you all the equations corresponding to different conditions that we have derived. For example, when the slope is dry, when there is a steady state seepage condition, and when the slope is completely submerged. So here the condition of steady state seepage has been given. So can anybody give the equation for factor of safety?
Yes, sir. Should I mention, sir?
Yeah,
Okay, sir. So factor of safety with respect to strength equal to c dash plus gamma dash cos square I tan phi divided by gamma saturated h sin I cos I.
yeah, very good. Others may please verify.
Sir, this two beta value is different. Why?
They are same. They cannot be different.
So beta is 25 and here beta is 15.
15.
So
Maybe
so which one should take
you can take any value.
15 or
No
20?
problem. Any you can assume anything. Whatever you like it. Now can I ask a simple question here? Suppose so here a small dot has been given. Suppose if I put a manometer here, and what would be the rise of water level in this manometer? Can anybody able to calculate? Suppose if this is the manometer, up to what level the water rises in it?
Ground level. Up to the ground level.
Up to the ground level. Are you sure?
So it's below the ground level, I think, where the seepage, up to the seepage pressure. Sorry.
Yeah, suppose from this dot point, so wherever this ground surface is there, from
Sir, I
there,
think, sir, 5.598.
suppose if you draw right from the top of the point in horizontal line, wherever this horizontal line cuts your manometer, that should be the rise of water level. So this is the water level height. So this is height of the water. So how do you determine this height? There is a formula that we have derived.
Yes, sir, 5.5 times, sir, meter.
5.5.
Sir, L cos square I, sir.
No, no, no. This is water height. I'm not talking about inclined height or inclined length of the element. I
Sir,
think that
then it
is
should be at 6.
capital H into cos square beta. Just verify.
Yes, sir. That's what I am saying, sir. L cos
Okay.
square I or beta.
Okay. So this is H cos square into beta.
Beta.
So this is,
So
what is the value?
5.598. 5.598 meter.
Okay. So 5.59 meter. Okay. So the total height of the slope is 6 meter, but the water level rise in the manometer is 5.59 meter. So refer to the previous class discussions on how to calculate this H. We have also derived. So the relationship between small h, that is water level rise, with the capital H, that is height of the slope or thickness of the soil. Okay, so these are the list of formulas for different conditions. If there is a steady state seepage, then this is the equation. Fs is equals to C dash by gamma sat into H cos square beta into tan beta plus gamma dash by gamma sat into tan pi dash by tan beta. And if there is no water, that is dry condition, for C pi soil, factor of safety is equals to C dash by gamma H into cos beta into sin beta plus tan pi by tan beta. Suppose if you presume that no cohesion component exists, if it is purely granular material, then Fs is equals to tan pi dash by tan beta. Tan beta. And if you can able to calculate the pore pressure parameter component as well, so this is the equation. Factor of safety is equals to C dash by gamma H into cos beta into sin beta plus 1 minus U by gamma H into cos square beta into tan pi dash by tan beta. So these are the summary of equations for different cases. Only water seepage. So water seepage with the measurement of the pore water pressure, then dry slope, then granular material, then submerged condition, so on and so forth. So you may note it down all these equations.
Sir, so this slope will fail, sir.
Okay, no problem. It may fail. How does it matter? Okay, so let me show you the solution because these equations are already available with you. So this is the equation. Fs is equals to C dash by gamma sat into H cos square beta into tan beta plus gamma dash tan pi dash by gamma sat into tan beta. So beta is here they have taken 15. Either you can take 15 or 25, doesn't matter. Okay. So gamma dash is equal to gamma sat minus gamma w and Fs, straight away substitution. C dash given as 10 kilopascals by gamma sat is 17.8, which is also given. Height of the slope is the 6 meter and beta is 15. Either you take 15 or 25, doesn't matter. And tan pi is given as 20. So 20 degree. So substitute everything. Then what you will get factor of safety is 0.985. So this is less than 1 means the slope will fail. Okay, so meaning thereby, so if you see any slope with angle of inclination of the slope as 15 degree and the thickness of the soil layer is 6 meter, if the slope is subjected to a steady state seepage condition, then it will fail. Okay, that is the conclusion that we can able to make from this problem. Is it okay? Everyone could be able to understand what is the meaning of all these calculations.
Yes, sir.
Very good. Now, where is the location of the failure plane? Where is the location of the failure plane?
So up to height 5.757 meter.
No. It is the interface between the soil and rock. Okay, it is the interface between soil and rock. Because the rock cannot move, na? Only soil can move along with the
So
water.
sir, we can say shear stress will be greater than the strength. So we can find the height from the shear stress.
Yeah, no problem. See, for example, now, if I ask you to calculate the height, critical height, okay, what should you do?
Put Fs equal to 1.
Put Fs is equals to 1, back calculate the h. That will be slightly higher than the, or slightly lower than the 6 meter. That's it.
Yes, sir, lower.
Yeah, so I repeat, suppose if I ask you to calculate the critical height of the slope, now put the factor of safety Fs is equals to unity. So this is unity. Now back calculate your h value. Your h becomes h critical. So when you calculate, then you will get slightly h as lesser than 6 meter. Okay, or alternatively, if I ask you to calculate what is the critical slope angle requirement of the same for a same 6 meter. Okay, so then again assume Fs is equals to 1, then try to back calculate the value of the beta. So that will give you the critical slope angle. Okay, depending upon your requirement. If everything has been given, if you are asked to calculate the critical shear strength parameters, that is C dash or pi dash, so still you can able to do it. Okay. The second part of this question is the same thing, part B. If Fs is equals to 2, what is the height of the slope? If Fs is equals to 2, so just read the sum. The height h that will give a factor of safety up to against sliding along the soil rock interface. So here simply substitute in place of Fs as a 2 and back calculate the h value. So 1.62 meter.
Sir, how can we find the location of the failure plane?
No, here it is not required. Na? This is an infinite slope. The failure plane always develops at the interface between two materials, here soil and rock. This is infinite slope. You don't need to talk about the location of the failure plane. Okay, so I will stop it here. Maybe tomorrow we can continue.
Sir,
Yeah.
sir, tomorrow I will be in train, sir.
Tomorrow you'll be in a train.
Yes, sir. I have journey in train today.